Welcome to Seco Gulf YouTube channel. In this video, we will explore the rotor 2D case in OpenFOAM, which demonstrates rotating machinery simulation in 2 dimensions. We will go through the set case setup, run the simulation, and visualize the results in ParaView. The rotor 2D case is part of OpenFOAM's tutorial library and is a great starting point for understanding rotating reference frames and steady-state simulations. This tutorial uses the SDR pimple foam solver and showcases how to handle rotational zones in CFD. Okay, so let's run the simulation. First, we have to go to the OpenFOAM tutorial library. Inside that, we have to go incompressible. Then we have to go inside SRF pimple foam. Here you will find rotor 2D. Okay, so we will copy this to our home directory. Then we will go to our home directory, and here it is. It has been copied. Okay, so let's go inside the rotor 2D directory. Okay, so the first step, we always check the system directory. So here is a thing, and the thing is like blockmesh.dict file has been given in .m4 format. So let's open and check what is this. Okay. So here you see that it is not the usual blockmesh which we were using. It is written in some different format. Okay, it is written in some different format. So what is this, and what is this format, and why it has been written in this form? Okay, so .m4 format is something which is a special one. Okay, so let us talk about that one. So this mesh setup has been written by the name of blockmesh.dict.m4. As you can see the name, it is written in .m4 instead of the usual blockmesh.dict. Okay, this is because the M4 macro preprocessor is used to make the mesh definition more flexible and parametric. Okay, with M4 we can define variables such as domain size, rotor radius, or number of cells at the top of the file and then reuse them throughout. This makes the mesh much easier to modify, as changing one value updates all relevant sections. Okay, so as you have seen that the radius, hub radius, impeller tip radius, baffle tip radius, tank radius, thickness, and all those things have been defined once. Okay, and then they have only used it later on. Okay, only mention the variables, not the value. Okay, so the thing is like we have to only mention the value once. Okay, so this is the hub radius, so r is equal to 0.05. This is impeller tip radius, so r is equal to 0.2. so here you can see that, for example, here they are using it as here they are using as rb0t. Okay, so only we don't have to change it again and again in all the lines. Only we have to make the changes here, and it will automatically changes all over where it has been required. Alright, so before we run it, it will not be run in a usual blockmesh. Like we cannot run this blockmesh.dict.m4 file by running this command. Okay, so we have to run it in a special way. So before we can run blockmesh, we need to process this m4 file to generate the standard blockmesh dict. Okay, so let's go and do it. So we have to go type m4 system blockmesh dict.m4, because it is inside system directory, so we have to write it like this. Then then system / blockmesh dict. Okay, so this is the thing, and we will press enter. Okay, So it will just okay. So pre-processed file is ready. Now let us run the block mesh. Okay, mesh has not been made. We again have to run the block mesh. Okay, so let us run it. I've copied the command, and this log is like it will make a log file of block mesh, like whatever things have been done. Okay, so we'll press enter and mesh has been made. You can see that log.block mesh has been written. Let's go inside that, check it. You can see that all the things have been written, and mesh file, it is usually mesh file which we usually run the block mesh command and it writes, so it is like that. Okay, so let's check our mesh in ParaView also. Okay, so just a minute, will take 10 to 20 seconds to open. After that we will just go with that part. Alright, so we'll go to wireframe to check the mesh, and here is the mesh. Okay, here is the mesh. You can see what a beautiful mesh it has been made. Alright, what a beautiful mesh has been made. Okay, so directly with the block mesh you can also make a circular mesh. Okay, not only makes the rectangular mesh, but you can make the mesh like this only. Okay, so this is the this is the result of using OpenFOAM. Okay, you can do anything as per your requirement as you want. Okay, if you wanted to use, you can do it in other way also, but it will be like, first you make a block mesh, a rectangular mesh, then you have to make all those things in a 3D model software, and there you can just with the help of snappy hex mesh you can just insert it. Okay, so either you do it that way or you can do it this way. This is a very new thing, and I also liked it because I have used it also first time, and it is like a very nice thing. Okay, you can see what a perfect mesh has been made. Here you can see that, okay, no distortion, nothing. It's a very beautiful mesh which has been made. Okay, alright. Okay, so let's go back, right, and yeah, now we have to copy this 0.org to 0 directory. Okay, and then we have to run the this simulation. Okay, so I'll press enter and it will start running. Okay, so it will run. I have seen the control rig file before, so it is, the end time is 2 seconds, so it will take some time to complete, and after that we will see the results in ParaView. Okay, so the simulation is completed. Now let's post-process the results in ParaView. So we have already made the .foam file, so we will just open it directly in ParaView. Apply, and here are the results. Okay, so this is the pressure results. I will play the results and see. Wow, what the results, what beautiful results we have got. You see how the pressure is like increasing while the rotor is rotating. Okay, it's good. Let's go and visualize the velocity. Okay. Good. So this was a quick walkthrough of the Rotor 2D tutorial in OpenFOAM. It's a great example to learn about rotating reference frames and steady state simulations. In future videos, we'll explore more complex rotating machinery cases. So subscribe, Seco Girl, and thank you for watching.